So yesterday we looked at solving different equations, but every example that we looked at was a linear equation, which meant that the highest exponent was a 1. We just had an x by itself with no exponent. Today we're going to be looking at what are called quadratics. So you should have learned about this in Algebra 1. So we're going to, it's going to be reintroduced in Algebra 2, and you're going to go a little bit deeper with quadratics. But we're going to be looking at how you can solve quadratics using the same steps that we talked about yesterday. Now, quadratics are equations that have the highest exponent of 2. In other words, you have an x squared in it. So if you see an x squared in the problem, that most likely means you're dealing with quadratics, as long as that's the highest exponent is a 2. So there's no x to the third power, x to the fourth power. If you see x squared is the highest one, then it's considered a quadratic. Now we're going to be doing the same steps of yesterday where we're undoing everything that's being done to x, but now we're going to be adding in this last step where we're going to be undoing the square to isolate the x. So we're going to be using inverse operations just like yesterday, but to inverse squaring we're going to use square rooting. So here if we have the operation x squared, to undo the square we take the square root. That's the inverse of squaring. It undoes it. So the square root is an operation. It's the inverse of squaring something. And really all this means, what square root means, is whatever number's on the inside, you're looking for a number that when you multiply by itself, you get this number. So in this example, if we're looking at the square root of 4, we're looking at what number, when we multiply by itself, does it give us 4. Now you may be able to do this one pretty intuitively. You may know the answer. And you might think, okay, 4 is equal to 2 times 2, right? So if I multiply 2 by itself, 2 times itself, which is 2, I get 4. So the square root of 4 must be 2. Now this is something very, very important. In algebra, when we use square root as an operation, it actually results in 2 solutions. So positive 2 is one of them, but the other one is the negative version, negative 2 times negative 2. So positive 2 isn't the only solution to the square root of 4. There's also negative 2. Because if I multiply negative 2 by itself, negative 2 times negative 2, I still get a positive 4. Okay, so the reason that square roots result in 2 solutions is because positive times a positive gives you a positive, and a negative times a negative also gives you a positive. So in this case, the square root of 4, we use this symbol. And this symbol means plus or minus. So we say plus or minus 2. So there's 2 solutions to this square root. Positive 2 and negative 2. This is a short way of writing it. There is another situation where you may end up getting the square root of a negative number. So if we were talking about negative 4, and we want to know what number can multiply by itself to get a negative 4, well, we just talked about in the last part that if you have a positive number times a positive number, you get a positive number. And if you have a negative number times a negative number, you get a positive. So let me write that out. So a positive times a positive gives you a positive. And a negative times a negative also gives you a positive. So the only way to get a negative number is to multiply one positive number and one negative number. So let me write that as well. So one positive number times one negative number is the only way that you can get a negative number back. So in this case, there are no numbers that we can multiply by itself to get a negative number, because we need one positive and one negative, so we can't multiply 2 different numbers. That's not how square root works. So when you have the square root of a negative number, this is what we call no real solutions. No real solutions. So the reason we call it real solutions is because we're talking about real numbers. Real numbers are just the numbers that you normally see, all the decimals, fractions. Every number that you normally see is a real number. There are other types of numbers which are called imaginary numbers or complex numbers, which you'll talk about in Algebra 2, but for today's sake, we're not going to get into that yet. We're just going to say no real solutions. So when we're solving quadratics using square roots, we have we're going to get either one of three cases. Now the two most common are these top two. Really, this one is the most common, then this one's probably the second most common, this one's the least common. So you're either going to get two solutions, and that's if you have the square root of a positive number, and that's when you do the plus or minus of whatever the square root is. Then you have the case where there's no real solutions, and that's when you have the square root of a negative number. Or you may have one solution, and that only happens if you're taking the square root of 0. And that's because 0 is not positive or negative, so the only number that multiplies by itself to get 0 is 0, and there's only one version of 0. There's not two versions like in this case where you have a positive and a negative version. 0 is just 0. So again, these are the most common ones, these top two. Two solutions if you have a positive number, no real solutions if you have a negative number. So here are two examples of solving quadratics using square roots. So if you want to pause the video and try them out on your own, and when you're ready, press play and I'll go over the solution. So for number one, I'm going to start it out the way that we started the problems yesterday. Using the order of operations, I'm going to talk about what is being done to my variable x, which is what I want to solve for. And then I want to figure out what I need to undo going backwards using the shoes and socks principle, that the order that something is done, you have to undo it in the opposite order. So if I look at my order of operations, the first thing that comes up is p, which is parentheses, but I have no parentheses in my problem. The next one is e, which is exponents. Do I have any exponents? And yes, I do. I have an x squared. So the first thing that's being done to x is it's being squared. The next step is multiplication or division. In this case, I have no numbers being multiplied to x, so there's no multiplication or division. Then I go to addition or subtraction, and I have a 10 being added to my x. So I have a plus 10. So, based on the shoes and socks principle, to undo what is being done, I have to go in the opposite order and use inverse operations. So to undo what is being done, I start with what was done last, which was adding 10. The inverse of addition is subtraction. So the first thing I'm going to do is subtract 10. And then, the first thing I did was square my x squared. So to undo square, I have to use the inverse, which is square root. So I'm going to do the square root. So let's go ahead and do those steps. So the first step is to subtract 10. So what I do to one side, I must do to the other side. So if I subtract 10 on the left, I have to subtract 10 on the right. That undoes the addition. I'm left with x squared equals 74 minus 10 is 64. So I'm not done because x isn't isolated. I still have the exponent of 2. So I have to undo that by using the square root. So I'm going to take the square root of both sides. What I do to one side, I have to do to the other side. Now this inverse operation means it's going to undo the square. So what I'm left with is just x. And the square root of 64, remember, it's a positive number, so that means there's going to be two solutions. I'm going to get a positive 8 and a negative 8. Okay, 64 is a perfect square, which is 8 times 8. Or it's also negative 8 times negative 8. So I have two solutions, which is positive 8 and negative 8. You can write your answer like this with the plus or minus sign, or you could write it two separate answers, x equals 8 and x equals negative 8. This also works. So two solutions. For example number 2, I'm not going to list out the steps of what's being done and undone. If you want to do it that way, feel free to do it that way. If that helps you, then do it. The idea is the more you do these types of problems, it should become more natural of what steps go first. So the first thing I need to do here is get rid of the subtraction. That's the last thing that would happen in the order of operations. So to undo subtracting 18, I have to do the inverse, which is adding 18. And what I do to one side, I have to do to the other side. So I'm adding 18 to both sides. That undoes this subtraction. I'm left with 6x squared equals 78 plus 18, which is 96. Now I need to undo the multiplication. That's the next last thing that was done in order of operations. Okay, exponents come first in order of operations, which means it's the last thing we'll get rid of when we're solving. So I have to divide both sides by 6. That undoes multiplication by 6. And 96 divided by 6 is 16. And the last step, I have to get rid of the square. So I'm going to take the square root on both sides. That cancels out the square. That undoes it. And I get x equals the square root of 16 is plus or minus 4. Plus or minus 4. There's two solutions. So here's another example. This one's a little bit trickier. If you want to try it, go ahead and pause the video. But this one, I'm going to go over the solution, and there's a little bit of a difference in this type of problem for you to see. So the solution for this one, we could list out the steps of what is being done using order of operations. But as you can see, here we have parentheses, which is the first thing that is done in order of operations. So that's going to be the last thing that we worry about. We want to get rid of everything else first, and then we're going to deal what's in the parentheses. So we do have an exponent, so that's going to be before we do the stuff in the parentheses. And then we have addition, so that's going to be the first thing. So the first thing we want to do is undo this adding 5, and that's going to be using the inverse, which is subtracting 5. What you do to one side, you must do to the other. That undoes the plus 5. And I get x plus 3 in parentheses squared equals 41 minus 5, which is 36. Now, I have parentheses and I have an exponent. In order of operations, parentheses come first and then exponents. So when I'm solving, I'm undoing, I go in the other direction. So I'm going to get rid of the exponent first, and then I'm going to deal with what's inside of the parentheses. So in this case, I need to undo this square. So to undo square, I'd use the inverse, which is the square root. So I'm taking the square root of this entire thing, since the whole thing is being squared. And what I do to one side, I have to do to the other side. So that undoes the square. And now what I'm left with is just what was in the parentheses. So I have x plus 3 equals, and I have the square root of 36, which is plus or minus 6. Now, I'm not done with this problem. Okay, I need x to be isolated. Now that I got rid of everything outside the parentheses, this is what I'm left with. Now I need to undo this plus 3 in order to solve for x. But the problem is that here I have two numbers here. Okay, I write it, it looks like one number, but because of this symbol, this actually means I have two numbers. So that means I need to split it up into two separate problems. Once you get to this point, you have to split it up into two problems. So I'm going to do one where I have x plus 3 equals positive 6. And I'm going to have one that says x plus 3 equals negative 6. And I'm going to solve both of these problems to get my two solutions. So the first one, well, both of them I'm going to be doing the same thing because I need to undo this plus 3. So I'm going to be subtracting 3 from both sides on both of these problems. So for this first one, when I subtract 3, I get 6 minus 3, which is a positive 3. That's one of my solutions. And down here, when I subtract 3, I get negative 6 minus 3, which is negative 9. So my two solutions are positive 3 and negative 9. Here are the last two examples for today's lesson. So if you want to try them, pause the video, and when you're ready to go over the solutions, press play, and then you will see the solution. So for number 4, this is a pretty simple one. We just have an x squared, and we have it equal to negative 4. So there's only one step that we need to do, which is to undo the square. So we're going to take the square root on both sides. That will cancel out the square, it will undo it. So we will get x equals, and on the right side we have the square root of negative 4. So there's no real number that when we multiply it by itself we get a negative number. So when we have the square root of a negative number, it's as simple as saying no real solutions. And that's it for that problem. For number 5, we have a little bit more steps to do. We have 4x squared plus 10 equals 5. We want to undo each thing one at a time. We're going to undo the addition first by subtracting 10 from both sides. That undoes the plus 10, and we get 4x squared. 5 minus 10 is negative 5. Then we need to get rid of the multiplying by 4. So we're going to divide by 4. That's going to cancel out. And we're going to get x squared. We can change this to a decimal. X squared equals negative 1.25. And then we got to get rid of the square. So we're going to take the square root of both sides. And as you can see, we're taking the square root of negative 1.25. The square root of a negative, as soon as you see that, you know it's going to be no real solutions is going to be the answer to the problem. So you have a Google Forms quiz over this lesson. It's 10 problems. Make sure that you choose all of the correct answers in the quiz. Okay, there's 3 answer choices. Some of them may have only one answer, some of them may have 2 answers, maybe it could have 3 answers. You have to pick all of the correct answers. Don't just pick one. If there's more than one correct answer, make sure you're picking all of them.